So our problem of the day is to evaluate the discriminant. Remember, that's the part under the radical of the quadratic formula. So b squared minus 4ac. So our b is negative 8. So negative 8 squared minus 4 times a, which is negative 5, times c, which is negative 2. And then we're going to simplify this. Negative 8 squared is 64. Negative 4 times negative 5 is positive 20. Positive 20 times negative 2 is negative 40. And then 64 minus 40 is 24. So it's a positive number. And if that was under a square root, there would be 2 real solutions, because all positive numbers have 2 real solutions when we square root them. Okay, so continuation, same learning intention and success criteria. We're learning about polynomials, linear factors, and zeros. We're going to factor higher degree polynomials, analyze the factored form to identify our roots, zeros, and their multiplicities. So if we are writing this in factored form, always take out our greatest common factor first. So looking at number 1, greatest common factor between these 3 terms would be x. When we factor out an x, we're left with x squared plus 8x plus 16. Then it's a quadratic, so our factors of 16 that add to 8, something that multiplies to 16, but when you add them together, they equal 8. That would be 4 and 4. So we can write that as x plus 4 squared, or you can write x plus 4 times x plus 4. And that is our final answer. On 2, taking out our greatest common factor, these both have an x, so I'll factor out an x, and I'm left with 4x squared minus 9. Now to factor these, this is a difference of squares. These are both perfect squares. So the square root of 4x squared is 2x, square root of 9 is 3. So we'll have 2x plus 3, 2x minus 3. We can't do 2x plus 3 squared. They need to be opposites. One's 2x plus 3, one's 2x minus 3. Number 3, taking out our greatest common factor, that would be x. We're left with x squared minus x minus 12. Factors of negative 12 that add to negative 1, because we have a 3-term quadratic, are negative 4 and positive 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. Can't factor that any further, so that's our final answer. On 4, kind of running out of space here, greatest common factor is x. We're left with x cubed plus 27. So this is a sum of cubes. These are both perfect cubes. Cubed root of x cubed is x. Cubed root of 27 is 3. And then we do this number squared, so x squared. And then we multiply these numbers together, so 3x. And then we square this number. 3 squared is 9. And then my signs are the same sign, so that's a plus, so this is a plus. Opposite sign, minus, and then plus. Same, opposite, plus. So this is my final full factored form. I have that x out front still from the beginning, and then we did factoring as a difference of cubes. All right, these next ones, we are finding the zeros, stating the multiplicity if it is more than 1. So if we just set each of these things equal to 0, it's already factored. So x plus 2 is 0. If we solve that, x is negative 2. X minus 1 is 0. If we solve that, x is 1. X plus 7 is 0. If we solve that, x is negative 7. And that is my full answer. That's it. On 6, we set each thing equal to 0. So x equals 0. That doesn't need simplified anymore. That's it. And then we have x plus 4 equals 0. And since it's squared, it'll have a multiplicity of 2. So when we solve that, we subtract that 4 over. So x equals negative 4 with a multiplicity of 2. On 7, set each thing equal to 0. So 4x equals 0, so x equals 0. X minus 4 equals 0. If we solve that, x is 4. X minus 3 is 0. That one has a multiplicity of 4 since it's to the fourth root, or to the fourth power. And if we solve that, we'd have x equals 3, and then that has a multiplicity of 4. And those are my solutions. 8 needs factored first. It's not factored yet. So our factors of 60 that add to negative 16 are going to be negative 10 and negative 6. Negative 6 plus negative 10 is negative 16. Negative 10 times negative 6 is positive 60. So then if we set each of those equal to 0, that means x is 10 and x is 6. 9. They're already solved. We just gotta, or already factored. We just gotta put them both equal to 0. So we solved this one. That would be x is 5. We would just add that 5 over. This one we would subtract the 1 over. So 2x is negative 1. And then divide by 2 to get that x by itself. So x is negative half. We did it. Okay, this last part. I know I'm moving really fast, but we literally did problems just like all of these Fridays. So I'm hoping this is just a quick review, refresher of each type of problem for you guys. Okay, so we are given the zeros. We're going to write the polynomial function in standard form. So if an answer was 3, that means we had to have started with x minus 3. If an answer is negative 3, we had to start with an x plus 3. If an answer is 1, we started with an x minus 1. We're going to FOIL these first two. They are conjugates or opposites. So we'll do first, x times x is x squared. The outside, inside, since they're conjugates, would cancel out. We'd get positive 3x minus 3x, and that's 0. So we can kind of skip that step. And then negative 3 times positive 3 is negative 9. So x squared minus 9 is what we get when we multiply those. And then we need to take that times x minus 1. So we'll FOIL that. They're not conjugates, so we actually got to do the whole thing. X squared times x is x to the third. Outside, that'd be negative x squared. Inside, that'd be negative 9x. And then last, negative 9 times positive 1, or negative 9 times negative 1 is positive 9. So x to the third minus x squared minus 9x plus 9 would be our final answer. 11, if we had a negative 2 as an answer, we would have had to have started with x plus 2. If 0 is an answer, we just had x. And then if 7 is an answer, we had x minus 7. So we can just distribute this x first, which would make that x squared plus 2x. And then we're going to take that times x minus 7. That's a 2 by 2, so we can FOIL it. So we do first, which would be x cubed. Outside, negative 7x squared. Inside would be plus 2x squared. And then last, minus 14x. And then we can combine our terms here. So we have x cubed minus 5x squared minus 14x. And that is our final answer. That pen is really fun to me, but I hope it doesn't stress you out that it's a lot of colors. Okay, our last one. If negative 2 is an answer, then we would have had to have started with x plus 2. If 7 is an answer, we started with x minus 7. And if 9 is an answer, we started with x minus 9. So there's no conjugates in this, no opposites, so we're just going to start by FOILing these first two. So we would do first, which would be x squared. Outside, negative 7x. Inside, plus 2x. And then last, minus 14. And we still need to take all of that times x minus 9. But before we do so, let's combine these like terms to simplify it a little bit. I'll switch colors because that's probably driving you guys nuts. So x squared, negative 7x plus 2x is negative 5x minus 14. Taking that times x minus 9. It's a 3 by 2, so to do this, I'm gonna find a better color. One moment. I like this one. Okay. We're gonna do the box method and do a 3 by 2 box. So x minus 9 on this side, and then we have x squared minus 5x minus 14 from here up across the top, and we're just going to multiply in each of these boxes. So x squared times x would be x cubed. X squared times negative 9 is negative 9x squared. Negative 5x times x is negative 5x squared. Negative 5x times negative 9 is 45x. Negative 14 times x is negative 14x. Negative 14 times negative 9, 14 times 9 is 126. And then we'll just combine our terms and we're done for the day. So we have x cubed, negative 9x squared minus 5x squared is negative 14x squared. 45 minus 14x would be 31x. And then we have our plus 126. I'm running into the box, but we're just going to roll with it. And that's our final answer. So that's all, review from Friday. That's why I moved really quick. Hopefully that gives you enough that you can get started on that assignment.